I made the classic mistake that I think every homelab enthusiast fears. I was updating the BIOS on my Supermicro X10SDV server motherboard, and then the power went out. When the power came back, nothing. Black screen. The board was completely bricked. Now, usually this board has safety features. It has a dual boot block and it has USB and IPMI for recovery. But none of them worked. The corruption was so deep that the system couldn't even wake itself up enough to heal itself. At this point, the panic set in. I thought I had to go out and buy a brand new motherboard, or at least find a donor board to swap chips with. But it turns out I was wrong. You don't need a new board and you don't need to be a soldering expert. Today I'm going to show you how to save a hard-bricked motherboard using a $10 tool and some patience. Let's fix this. First, let's talk about what actually happened. The BIOS chip on this board is an SPI flash chip. Because the power cut happened in the middle of a write, the data on there is garbage. Specifically the boot block, the tiny piece of code that tells the computer how to turn on, is corrupted. That's why the built-in USB and IPMI recovery failed. They need that boot block to be alive to work. So we are going to bypass the CPU entirely and write the data directly to the chip. To do that, I am using a CH341A USB programmer. You can get these online for cheap. This clips directly onto the BIOS chip, so we don't have to solder anything. A quick but critical warning. Voltage matters. The Supermicro board uses a 3.3 volt flash chip. A lot of cheap programmers provide 5 volts by default, which will fry your chip instantly. Please check your programmer and make sure you are outputting 3.3 volts. If you are not sure, please use a multimeter or a voltage adapter. Don't skip this. For the software, I'm on Windows, but I am avoiding those sketchy random programmers that you can find on the forum. We are going to use Flashrom. It's the industry standard, it's open source, and it's much safer. To make it work on Windows, I used a tool called Zadig to install the WinUSB driver for the programmer. It takes 2 seconds and ensures that Flashrom can see the device. Okay, the server is unplugged. And I mean fully unplugged, no power cables attached at all. I'm clipping the tool onto the BIOS chip. I have made sure that pin 1 on the clip matches the dot for pin 1 on the chip. Now over to the computer. We are going to run a detection command. It's a Winbond W25Q128. That's 16 megabytes, which matches the size of the BIOS file I got from Supermicro. Step 1 is always a backup. Even though the BIOS is broken, I am reading the contents to a file. Why? Because the chip also holds board-specific data like MAC addresses and UUID. If something goes wrong, I want that data to be saved. I've got the official BIOS image from Supermicro, version 4.205 for the X10SW. I am writing it directly to the chip. This is going to take a few minutes. It's erasing the old corrupted data and writing the new firmware, and then verifying every single byte. Okay, Flashrom says verified, and that's the golden ticket. I am removing the clip and I'm plugging the power supply back in. Now, the first boot after a deep flash like this can take a scary amount of time. Sometimes 4 or 5 minutes while the BMC reinitializes and the memory drains. And there it is, the splash screen. We are back in business. So we went from a dead, unresponsive server board to a fully working system just by externally programming the SPI chip. We don't need a donor board and we didn't lose our hardware. If you're running a home lab, I highly recommend keeping a CH341A in your drawer. It's the ultimate insurance policy. I have put the comments I used and the links to the tools in the description below. In part 2 of this video, I will show you how to revert your board-specific details such as serial number, MAC address, and FRU configuration. If you also think that the Supermicro X10SDV is the best motherboard for homelab, follow me and I will cover many interesting topics such as virtualization, infrastructure as code, out-of-bound management, and more. If this saved your hardware or you just enjoy seeing things fixed, please hit that subscribe button. Thanks for watching and I will see you in the next one.